subtracting fractions, basically. And what's the one rule you have to have when you're adding and subtracting fractions? The common denominator, combinator. We'll call it that. You gotta have the common denominator. So you think back to what you did here. 2/3 plus 1/2. If you had to do that by hand, because Lord knows you all forgot how to do that.
I know how to do
What?
that.
Well, how do you do that, Mr. Suter?
So you get the greatest common factor between the three, or not greatest, least.
Yes.
Whatever. You know.
Okay, so in this case, what's the least
6.
common multiple or least common denominator of both? 6. All right. So in order to make this work, it's got to be something over 6 plus something over 6. What do you have to multiply the 3 by to turn it into a 6? 2. So you have to multiply top and bottom by? That's what you're doing. You're multiplying it by a factor of 1. You're multiplying. When you did this way back in the day, in order to get common denominators, what you were doing is you were multiplying stuff by a factor of 1. And whenever you multiply something by 1, it doesn't change. And that's what we're doing here. What do you have to multiply it by to turn it into something else? And you were happy. Well, it doesn't change when we do stuff like this. Yay!
That was fun.
Yes.
It does.
Yeah, that X though.
So what? Who cares if there's an X there? Look at it. If I wanted to add those two together,
9 over 3x.
what do you mean it doesn't look like fun?
So it'd be 3 over x. 3x squared, or 6x squared?
Careful.
Or 6x.
Hold on. Wait.
No, it's just 6x because you're not multiplying. I got it.
I'd say it's 9.
3x.
Let's all stop for a second and let our brains catch up with our mouths. First thing you're going to ask yourself, do you have a common denominator?
Yes.
If you have the common denominator, let's just write it down. Oh. No, I just wanted you to slow down, that's all. You know how to do this, we're thinking too fast.
Next year sub, he always let me like go and think I was right, and then he'd like stop me and be like, "You're wrong the whole time."
That's Seth, though. I'm much nicer. What's 4 plus 5?
9.
All right. Now, can you do anything to this?
Yeah.
What can you do?
Simplify.
Simplify, what do you wind up with then?
3 over x. Oh, x, that's it.
Okay, and you're done. Now, the reason that I can do that is because both the numerator and the denominator are monomials. There's no addition or subtraction there. They're all being multiplied together. You can do that. If I look at the next one, do I have a common denominator?
Yeah.
So I write it down.
Oh, it's subtraction.
What do you do in the numerator then? Is there anything you can do with that then?
No. Nah.
No. There's nothing left you can do. Now, I could factor out a GCF in the numerator of a 2, but does that get me anywhere?
No.
It doesn't. There will be times that it might occur that you can factor out some GCFs here or there to simplify out like you did yesterday. But at this point, when you're looking at this 2x minus 4 over x plus 3, you're done. There's nothing left to do. Not bad, right? Okay. So, well, we did this. That's easy. Let's just start with all the fun stuff right off the bat. Why, dilly-dally around the inevitable?
I think we should.
So you this is funny.
How do we
So here's what we're going to do. When you start these problems out, what you always want to do is you're going to factor out your denominators to try to figure out what your least common denominator is going to be. So we have 5 over 6x squared plus x over 4x squared minus 12x. With those two parts there's only one of them that I'm going to be able to factor. The second denominator. Everybody okay with that?
Yeah.
So when I do that, I'm just going to rewrite. I have 5 over 6x squared plus, what do I do here? What can I factor out?
Factor 4x.
Take out the 4x, and I'm left with x minus 3 all over x. We okay with that?
Yeah.
All right. Now, what's that? Oh, sorry, under x.
Who doesn't like it?
Now, at this point, What can we do?
Get rid of the x and the x.
In this case, I can, because in just this, it should have worked. Whatever. In here, since it's x over x, there's no, I know I was trying to be cool. There's no addition in the numerator at all. I can simplify those x's out. What goes in the numerator?
What?
1. We okay with that?
Yeah.
Sometimes you'll be able to do this, sometimes you won't. Now, if I didn't do that, is it going to hurt me later on? No, it's not. You'll just have to do some simplifying later. It's usually easier to simplify first because you'll wind up with less of a, not as large of a term in the end. Okay. So if I'm looking at this and I want to get a common denominator, I have numbers, I have terms, and I have some like x squared thing going on. So we look at it in terms of numbers first. What's going to be the least common denominator of a 6 and a 4?
24.
Remember, you're going into multiples. Yeah, 12. Are we okay with that?
Yeah.
So the denominator is going to have a 12 in it. Now, on this side, there's an x squared. Is there an x squared here? What do you got to do?
Couldn't you just like multiply them by their opposites or something?
You can, but it gets to be larger than it needs to be. Then you'll have to do a lot of simplifying later. Okay. So now I have on the left fraction an x squared, on the right fraction an x minus 3. Since those are both individual terms, they need to be part of the denominator. So it's going to be an x squared and an x minus 3. That will wind up being the common denominator. Are we okay with that?
Sure.
Yes.
Wait, and then you're supposed to like multiply the bottom, so it'd be like 10 and 3.
Now-
13.
Hold on. Don't get ahead of yourself here. So the fraction on the left, we need to turn the 6 into a 12. What do you have to multiply it by?
2.
2. So I have to multiply the top and the bottom by 2. Still a factor of 1. You okay with that? Does it already have an x squared?
Yes.
So I don't have to worry about that. But what does it need?
X minus 3.
It needs an x minus 3.
I get it.
In order to have the common denominator, see how it's missing the x minus 3, but it has the x squared? So if I multiply the top and the bottom by 2x minus 3 times 20x minus 3, isn't that still a factor of 1?
Yeah, so
Yeah.
then you have like 10
So I have 10x minus 3 plus, well, this side, to turn the 4 into a 12, you multiply it by 3. It has the x minus 3, but it needs the,
x squared.
so you multiply top and bottom by 3x squared.
And then can you like cancel the one?
What does it happen?
No, because
We're simplifying
that.
We're actually adding.
I
We're
get
adding
it.
residues.
Yes, Anne?
So I understand the part where you have the 2 on this side.
Yeah.
I get it.
What I'm doing there with the, how do I turn the 4 into a 12? That's why. I turned the 6 into a 12 by multiplying it by 2. I turned the 4 into a 12, I have to multiply it by 3. I'm just working with different values to make it work. Okay. Yes, sir. Hold on, guys.
Why are you multiplying both sides by 2x minus 3 instead of like 2 squared?
Because this side here already has an x squared in the denominator, it doesn't need it again.
Oh,
Okay?
yeah.
Now, if you did that, you multiplied it out, you'd wind up canceling it out anyway. I'm just trying to go with the least common denominator to make it less cumbersome in the long run.
And that's where the other side put the 3 as well. It doesn't have it on that side.
Now, it does, nothing cancels out here, guys, because you have the addition symbol. Okay? So what you do now is just combine like terms and distribute in the numerator. When you do that, you wind up with 3x squared plus 10x minus 30 all over 12x squared x minus 3. And I'm done. Don't multiply out your denominators. Always distribute and combine like terms in the numerator. Yes?
Can you factor in your brain at all?
You could try, but usually it doesn't.
That would be hard.
Okay? Usually it doesn't. What times what's 90 to get you to 10? 9 and 10, yeah, it's not going to get you there. 9, it's 9, 10, 3, 30, 15, and something. 6? 6, and none of them get you to 10. So you don't have to worry about it, okay? That would be your final answer. And like I said, it takes a little getting used to because it's something you probably haven't done in quite a long time. Okay? Let's try another one. I'll make it easier.
Easier, aka.
No. This is a lot easier. I wanted to hit you over the head with the most complicated, well, one of the most complicated, get you at the idea of what's going on. Now, when I go to something like this, I'm looking at my numbers first. What's going to be the common denominator of a 5 and a 3?
15.
Guys, what is going to be? 15, good. When I'm doing the numbers first, I know I'm going to have something over 15, but now when I deal with the variable, they both have an x. So they already have that in common, so all I have to do is put an x. No, because they both have 1. Okay. So the common denominator there would be the least common denominator. Isn't x squared greater than an x?
Yes.
That's why. Okay. So now, what do I have to multiply the fraction on the left by?
3.
3. When I multiply the one on the right?
5.
Okay.
You're 61.
Okay, so you guys are getting a little ahead of yourself. You're not that advanced.
So the numerator becomes 21 plus 40, otherwise known as? And that's it. That's how you would add those two together. Like I said, don't freak out about the only taking a little bit of time. It's just one of those things. You're factoring. You're looking for the common terms. Okay. So let's do it with subtraction then. Let's move this over so we can do this. I have x plus 1 over x squared plus 4x plus 4. Yes, ma'am?
Do you factor out?
Yes. You got to factor first. You always factor first. Because that's how you're going to get your common multiples for what are your common terms in each one of them. Okay? And this becomes one of those handy things is if you're writing this out, factoring it as you're going, it just saves you a little bit of space. So I'll give you a second to write that one up and we'll go from there. So as I start to factor this stuff out, we get x plus 1 over x plus 2, x plus 2, minus 2, x minus 2, x plus 2. Do we agree?
Yes.
Okay.
Yeah.
So now when you go through these things, what denominator do they both have in common? They both have an x plus 2. So they both have an x plus 2, so we put one of them down. We've taken care of their commons. What's left?
Another x plus 2.
And there's your common denominator.
So you don't.
What you're doing here is you're looking to see what they have in common. Whatever they have, one of them in common, you just write one of them down. Then what's left? Fill in the blanks. Okay. So now if I come back, I didn't mean to erase this. Cross that off, sorry. So now if I look at the fraction on the left, notice what it already has. It has 2 of the x plus 2's. What is it missing?
X minus 2.
So you have to multiply it by?
X minus 2.
That's it. So the top's going to be x minus 1, x minus 2. sorry, I looked bad.
Why is the X plus two?
Oh, thank you. So I have an x plus 1 times an x minus 2. The fraction on the right then, it's missing a what? It's missing one of the x plus 2's. Once again, distribute, FOIL your numerators, leave the terms in the denominator. I FOIL that out. We should get, was it x squared minus x minus 2. You okay with that?
Yeah.
And then on the other side, it'll be minus 2x minus 4.
Okay.
Because I'm distributing out the negative 2 to both parts.
And you leave the denominator the same.
Yeah, so now when I combine all my like terms here, we wind up with x squared minus 3x minus 6. Are we okay with that?
Yeah.
All over
X
x plus 2, x plus 2.
Are we allowed to write x plus 2 squared?
Yes, if you want, that's fine.
Okay.
I have no problem with that. I usually just go the longhand, unless there's like 5 of them. And you're done. What you're going to screw up, because I'm, know what you're going to do, is this. It's negative 2 times the x, negative 2 times that other part, the plus 2 there. That's what you're going to screw up.
Wait, you can't do it like that?
No, that's how you do that.
Oh.
I'm saying you're going to screw that up. You're going to forget that it's a negative 2.
Okay.
Okay, so just be careful. All right? So, do this one. So when we do this, your common denominator is going to be x minus 4, x plus 3. What's the fraction on the left missing? So it becomes x plus 3, minus 6 times x minus 4. Distribute, combine like terms. X squared plus 3x minus 6x plus 24 simplifies to be x squared minus 3x plus 24 all over x minus 4 x plus 3. Okay. Do you guys see how I'm not rewriting my denominator when I'm simplifying my numerator?
Yeah.
It's just just saving space. It's not going anywhere. You don't have to multiply it out. Okay?
Oh, you
No. Denominators don't multiply out. Numerators, yes. Numerators, you always multiply out and combine like terms. Denominators, just leave them as their chunked out terms. Okay? Where's my Burke asymptotes for this? 4 and negative 3.
Are we gonna have to do all this math and then graph it?
No.
I can't remember.
Because then if you get that wrong, you get that.
It's bad news, man. It's bad news. All right, let's make it even more fun.
a fraction in our fraction.
Make me want to kick
You got some
I'm not killing any puppies.
Make me want to kick
Don't kick a puppy.
So I can see what I can't reach it.
Don't do this a lot. I hate this kind of.
Thank you.
You're welcome.
Why do I feel like why do I need to know this?
Hey, that's what I gave you.
You guys in your wambulance. Sorry, a little late on the wambulance. So stop with the wambulance.
Like, that's what we sound like.
Yes, to me, this is what you guys sound like.
Right when you put that
It could have been one driving by.
There was.
No, there was not.
So let's look at this one then. Let me just bring it on another one.
I just didn't understand.
Do you guys know what this is called besides crap?
The factor, the fractions of the fraction.
It's called a complex fraction.
Okay. Good enough.
And you guys have actually done this before, but you've done it where it looked like this. 2/3 divided by 4/5.
Never seen that one.
It's vertical division of a fraction. If I rewrite that, if you rewrite this, you would get 2/3 divided by 4/5, which then becomes 2/3.
Times by 4. And then you get 10 12.
Or you just, okay. Sounds good.
And you get 5/6, right?
Sure.
Because I simplified.
I think that was good.
Okay. So what you've done here is, in the past, you've done this crappy looking complex fraction with vertical division. You rewrote it horizontally, multiplied by a reciprocal, and you were done. Gee, what do you think you're going to have to do here?
The same thing.
The same stinking thing.
Wow.
Okay?
What happened here?
So when we do it that way, oh, we'll eventually get to the right spot. When we do that, if you look at it, the numerator, the top fraction, there's really nothing that I need to do to that, right? No. The bottom one I have to get a common denominator though, right? In order to take care of that. So the common denominator here is going to be what?
X plus 2.
Perfect. So down here you have an x times an x plus 2. And what's the numerator become?
X plus 2.
Perfect. X plus 2 times x plus 2. And I heard people are already simplifying it, and that's okay. Everybody okay with that?
Why
Yeah.
are you even simplify that?
Yeah, where'd you get access to that?
Because you have to do the things.
See how this doesn't have, this fraction here doesn't have an x plus 2? So you have to multiply it by the x plus 2. The 1 didn't have an x, so I multiplied 1 times x.
Oh.
Yeah.
So now when I simplify out my numerator, I get 3x, that's weird,
Oh.
3x plus 4 over x times x plus 2. Are we okay with that?
Yes.
The,
Oh. Never mind.
the big numerator then is still 2x plus 2. So now all I'm going to do is just rewrite it horizontally. You've already simplified out that denominator, so rewrite it horizontally. You get 2 over x plus 2 divided by 3x plus 4 over x times x plus 2, which means you multiply by its, not opposite reciprocal, we're not talking slopes, not opposites, we're just doing reciprocals. You get it eventually. Now, a lot of you might be able to just go ahead and flip it right away, which is fine.
Is he moving up in the world?
Is she getting taller? Sorry, is it?
Collar. Yes, collar. Yes, you got a collar.
Did you get her collar?
Woof, woof.
So now what simplifies?
The,
X plus
So you're left with 2x over 3x plus 4. Now, some of you guys might have noticed that if you're working with that, when you're going from the complex fraction here, instead of switching directly from the complex fraction to the horizontal, sometimes people just go ahead and flip this right away, just to save space. That's okay. Not a big deal. I just wanted to show you what that meant instead of going from vertical fraction to division to multiplication. I'll just show you within a couple of steps. It's not a very complicated process. It just takes a little bit of time. No, not just that. What's different here is that you're adding, you're subtracting. You're getting that common denominator prior to working with simplifying. That's all. You have to get all the common denominators prior to being able to add and subtract. When you're multiplying and dividing, it doesn't matter. You just multiply straight across. When you add and subtract fractions, is what always is a big pain in the butt. You have to get those common denominators. All right, let's look at another one.
That sounds really weird.
Try this.
So you take this another complex.
So I have x over 5 plus 4 divided by 8 plus 1 over x. Hold on a second. Write this down. Now, when I'm looking at this, I might right away put the 4 over a 1. Think about it. It's the first Tuesday in December. It's the wind bullets, yes.
No, there's definitely a
Well
fire.
played, air 5 for that.
Oh, that's a weird.
It was pretty weird. What's the common denominator going to be for the big fraction up top? 5, everybody agree?
Yeah.
Okay. Does the fraction on the left have the 5 already?
Yeah.
Yes. What does that have to be on that side?
Oh.
I got to multiply the 4 by?
Like 5 times 4.
Well, it equals 20.
I know! Gee, stop yelling at me. Are we okay with that? Do the same thing with the fraction on the bottom. That common denominator is going to be an x. I have to multiply the 8 by an x, but do I have to multiply the 1 by the x?
No.
So now I have x plus 20 over 5, all divided by 8x plus 1 over x. So when I go to rewrite this whole thing out to finish simplifying, I get x plus 20 over 5. I'm going to do my flip right away. Since I'm dividing by 8x plus 1, I'm going to multiply it by x over 8x plus 1 to give me a final answer of x plus 20 over 5, 8x plus 1. Which, I mean, I left it like that just to see if there's any terms that could simplify, but nothing in this case. So it would be, what, x squared plus 20x. You're done. Yeah. Oh, whoa, 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 Yeah, that's why I said it was just x squared. Okay?
Wait, do we not do the bottom?
No. Don't ever worry about denominators. Numerators is what I usually take care of. All right, do this one. Really? So with any luck, you got a common denominator up top of 5. So you have x plus 2 minus 25. You okay with that? But then that becomes x minus 23 over 5.
I thought you had to do that like square, or not one.
23.
Quantity of
Yeah, like I thought, like,
Yeah, that's what I thought.
Oh, no, because if you look at the denominators here, you're just looking for the denominator, it's just 5 and a 1. So this one already had the 5 underneath it. This one didn't, so you just have to multiply it by 5. Okay?
Wait, do you have to put them on the
No. Not in this case, because it already had the denominator, so you don't have to worry about it. Do the same thing with the bottom. Your bottom is going to be, excuse me, over x. The 8 needs an x, the 4 doesn't. 8x plus 4. So now I have x minus 23 over 5 divided by 8x plus 4 over x, sir.
Why is it for the bottom of the bottom fraction, why is it x and not 1?
This has a 1, this has an x. What's common between a 1 and an x?
Why is it
Be 1x, actually. In order for it to work, you have to have the combination of both of them. What do they have in common? Nothing, so you multiply them together and get x.
Oh, okay.
So now you just wind up doing x minus 23 over 5 times x over 8x plus 4. I just flipped it right away. Final result of x squared minus 23x all over 5 times 8x plus 4.
Can't you do 20?
Wait, so if you were to multiply those, would it be?
You can factor out a 2 here if you want, but it's not going to get you anywhere. I think sometimes the book might do that, where if you take out a 2, you get 10, you have a 4.
Then you take it 4.
Oh yeah, you can take out a 4, duh. So this would be 20. We'll give you 2x plus 1. It's rarely going to get you anywhere up top. Sometimes it might. It's rare though. Okay.
Alright. No.
I don't know if I want to do all of that.
I don't know.
How much
It's
is
not that
it?
much, it really isn't much, but I don't think I need to worry about some of those, so.
I just need to know.
Let me look at this. I wanna change- I was looking at this morning, and I don't think we need to do that.
It costs all that. Oh, so she paid. Yes, dude. There you go. You were winning last night. Okay. Wow. Is he paid for dinner?
Do those. All right.
So basically he's paid for Friday.
Let's do those. Number 17, then 31 through 45 odds. Okay? That way it gives you a chance of checking to see if you actually did it right, which I hope you did.
I'm gonna do this here because I don't want to.
All right? Every single one of these is going to need a common denominator.
I only made you.